Today we are going to continue our discussion about chapter 13 and 14. Particularly, we're looking at the issue of virtual function or polymorphism in a more, I would say, an interesting application of the concept that's actually leveraging the idea of polymorphism in terms of doing the modeling. One of the issues that you probably heard about, I feel this is important for all the object-oriented programmer. Object-oriented modeling is very good in modeling about the information, the passive information, the passive part. For example, the class hierarchy to represent inheritance. It is actually, you can view as a representing the information in its right class or the right place. And also, it's excellent to actually have this something called containment hierarchy. Basically, you can actually describe abstractively what is a person, what is a thing, what is a motorcycle. And that is actually great for data analytics. So what is data analytics? By the way, data analytics is a broad area in the modern information technology as a tool for us to understand data. And therefore, the object modeling is very useful in terms of data analytics because you use all the computational tools such as statistics, machine learning, but you actually need to access the data. And the data, there are two kinds of data. One is what we call structural data. And you will learn something like such as database or relational database, particularly or SQL. That is what we call the structural data. In some sense, each of the class is also a table or a class or a structure. And then we basically use that to represent the information. But then in the data analytics, the other part is what we call non-structured data. And the typical example when people talk about non-structured, people really practically talk about JSON. So essentially, is how do you actually be flexibly represent something which I have no idea the complete picture about the whole thing. It must be extensible. It must be very flexible to represent. So far, you actually learned the tool for you to handle both structured and non-structured data. So that's called data analytics. But the midterm exam question I presented on Wednesday is actually going to have the third element. So remember, there are three requirements. Requirement number one, what's the class hierarchy? What's the inheritance? Requirement number two is has a relationship, is a containment hierarchy. And anybody remember what's requirement number three? Is actually interaction, communication among the object, right? So if you think about that, when you design a data analytic, you can passively record such a interaction. And usually that interaction is actually given to you. So you basically analyze the interaction as the data itself. So that's why data analytics really powerful to understand all the data has happened in the past. And they probably can predict what's in the future. But the thing is that in the example of when we design how motorcycle need to talk to car, it's really, there is an active perspective. Or the big black wolf, when he is trying to talk to Little Red Riding Hood, there is a online modeling we need to worry about because it's something which hasn't happened. We have to mandate, we have the The difference between passive and active is that in the active, we actually can design how the interaction should happen instead of somebody else design the interaction, and then we just follow that. And by the way, object-oriented programming can provide that very important perspective. And that is actually a very useful tool when you want to deal with a system that's actually going to represent a more active phenomenon. I mean, to be honest with you, in my opinion, that the software industry or whatever, the IT industry is actually get to pretty mature in terms of handling the passive, handling the what we call the data analytics. That part has been really mature in terms of IT technology. What you need to do is what's actually not being done over there is essentially try to understand more about the business logic if you're doing business analytics, or you try to understand social science when you want to do some of the social network analysis. So the thing is that part is actually quite mature from the computer science contribution. However, the active part is actually something which I believe is actually going to be very useful for next 5 to 10 years, because we really need a lot of this kind of real-time interaction, especially when we talk about autonomous car or any kind of robot, any kind of IoT, when they interface with human. There is a lot of interaction we need to model. We need to, I mean, when I say model means model, then I can actually realize that. Okay, that is a motivation for me to start the next chapter about my, is still the same chapter, but it's a chapter about what I'm about to talk about. So I'm actually going to talk about a concept called shadow object. I mean, the name might be a bit misleading. You can call it shadow object, you can call it proxy object. But the thing what we want to do is that if you think about, here is a fundamental issue. If I want my car to talk to motorcycle, it's not just a car talk to motorcycle, there's really an object representing the motorcycle and talking to an object that's actually representing the car. It's really object talk to object. If you think about that, in the object-oriented world, pretty much everything, soft, hard thing, they're all represented by objects. So basically, you're thinking about two objects, how they're going to communicate with each other. That's why the third requirement for you to understand the interaction. However, there was a problem with your, I didn't ask you to do this for your midterm, but I want to tell you the limitation. So far, what you guys has learned about object-oriented programming is essentially an object talking to the other object under the same program. So you compile your program, you set A out. And your A out basically include both your person object, your thing object, and then they interact with each other. Well, in reality, that's not going to be practical. In reality, it really has to be distributed. Means that the object is going to be reside on your phone or my what do you call pacemaker in my heart. You can check whether I have one here. Okay.
What about EVI?
That could be right. You could have all kinds of situations. The object could be anywhere. In fact, it's interesting. There is even a design of the object that every human being, the user, is actually being modeled as a psychological object. So there is a paper I read called Object-Oriented Psychology. So they basically using the concept to model the human, a real human, and then interact with an object. For example, an object in your phone, for example, or a database. So what I like to teach you is that how we can design very easily a system that allow us to have multiple programs across the internet, across any type of network, say Bluetooth network, it could be the possibility. and such that I want to be simplify the first one, such a C++ object on this device can actually talk to a bunch of other C++ objects in other devices. In fact, later you will see the power basically can be very easily extended to handle any type of object. For example, you could have a Python object talk to a Java object, and then C++ object is doing something else. When you have a distributed system, you don't worry about, hey, this one is Linux, this one is Windows. They will be able to, how do I say that, provide a general interface at the application level or object level such that you don't even care whether you're running on what kind of device. Okay, so that is the capability I'm going to teach you. And then I'm going to say the way I realize this, I'm using polymorphism. I'm using C++ virtual function to actually do this. Okay, so the first mechanism I want to share with you is called shadow object. So what is a shadow object? Again, the name, I actually should probably change it to proxy object. But let's actually say that this object here is the real object you want to talk to, assuming this is a server or this is the motorcycle I really want to talk to. Okay, so what's the possibility? Possibility one is that, where's my phone? Okay, so this is my phone, and I have an object program in my phone running, and I want to talk to that particular object in another device. Maybe it's a motorcycle, autonomous motorcycle. And the thing is that one of the things I can do is that I can actually build in a lot of intelligence in my phone. So basically I say, okay, how do I actually locate this object? Okay, by the way, if you want to talk to that object, you have to have the network address, right? You have to know what's the IP address to connect to this one. If it's a Bluetooth, you have to know the Bluetooth address as well. So you have to have the network address over here, number one. And number two, you have the other issue. You have to know what's the object identity of this object, because that particular autonomous motorcycle, they might have a 1 million object. And they might have 1 million objects of the same class. And how do you know which one you're going to actually connect it to? And the thing is that then you have to find a way to not just realize the network address, but also you have to know the object identity of that. So basically, when I make a call to that object, it will be forwarded to the right object. So you can think about that. At some point, if my phone need to communicate with a large number of the remote object, now I use the term remote object, then I have essentially some kind of management on my phone. So I know, okay, I'm talking to this one, I'm talking to this one, I'm talking to this one. And that could be a nightmare for any kind of programming, try to understand. Okay, so what we have provided, what is a shadow object? Shadow object is that, okay, essentially, if I know I want to talk to this object, I have a way, okay, by the way, this part you cannot bypass because this is actually, you have to know the identity, the network address to actually reach that. And what you need to do is that, do it one time. Whenever you want to communicate with the object, you actually, as if that this object is local to you. So you kind of bring a proxy or a shadow of that particular object, and then you actually bring it to your local phone. So in my phone, instead of now the programmer, when I write the program, instead of for me to worry about here is one object, there is another object, in my phone, as if I have all the objects already in my program. So essentially, let me tell you the difference shadow object is trying to accomplish. Say, instead of having you try to put the burden on the object-oriented programmer and try to say, hey, you need to be responsible for understand how do you communicate with 150 ecs36b student and to interact with the object in their phone. What we would like to do is I create 150 shadow object representing each of you on my local phone, on my local program. So now my programming is as if that you have been doing up to this point. Everything is local. Everything is in a single program. And the thing is that that shadow, the only thing they're doing is, that's why we call it a proxy, or sometimes we call it a wrapper, and such that whenever you interact with that object, it will be relaying that request to the real destination where the object really physically is. So conceptually, we kind of separate. It's nothing magic, but essentially what we're doing, we separate the communication mechanism to every single of this object from the logic that you want to interact with that object. So
what is the difference? Say, okay, I know the object, I know where it lives. Why would I go and take a copy of it on my server, which will create an extra memory? Okay, if I have the information, I can just store it in the JSON object, and every time I want to talk to that object, I have a hash map that will access its IP address and just ping the object at the IP address requesting information. Like, why go through a shadow object?
okay, let me repeat your question. So why is a problem for me to manage this separate myself, right? Manage to say a hash IP address about where they are, and then I decide what to do, right? I mean, why is this a extra layer, a major trouble? Why do I just do Eamon just suggest? Okay, in some cases, in fact, it makes sense to actually let the programmer be, how do I say that, be exposed to this detail. But in some cases, the situation could be complicated, is such that is a bit unnecessary. Let me actually give you an example. Do we believe that the object will always stay in the same place? The object will always be staying in the same place. So meaning that I want to deal with an object. And this object today is actually in Eamon's phone, is on your phone. But tomorrow, somehow, you want me to actually, assuming you trust me, you want me to handle this for you, and such that your object is actually moved to my phone. So for example, there are certain things I feel I really want, Eamon really cannot handle this. They want Felix to handle that. So in some sense, your object is actually moving to my phone already. So there is a mechanism, it's a dynamic, so we have to track. But look at my phone right now. So my phone is actually, I want to communicate with this object. But the thing is that sometimes this object is remote, sometimes the object is local. And the thing is that, do we want the programmer to actually be aware of this mobility or this changes? Because if I, as a programmer, I care that this object is local or it's remote, because I have to deal with them somewhat differently. I have to remember that. So do we want the programmer to be aware of that? Or we separate. Well, I'm not saying that problem doesn't exist, but can the programmer, is that better for the programmer only worry about this is an object I want to deal with without actually worry about where they really are?
But okay, so but at the same time, the shadow object has to keep track where the original object is, or at least if the original object goes remote, it has to broadcast its new address. Like, hey, if you need to ping me, this is where I am.
Right.
But how's that any different? I mean, I do understand, like, hey, if there's an object, let's take the object,
Right.
and every time it's called the object. But at the same time, I'm like, okay, I could spend an extra hour and save much memory by just writing my
Right,
own,
right.
save it.
You can do that. The thing about the other example, some of you might not familiar with this concept called DNS, domain name server. So domain name server is translation between the name to the IP address, right? So essentially, it's a separate layer of service that provide you to do the mapping. And it's an infrastructure to allow us to be able to handle. When I'm handling 10 objects, that's probably okay. If I want to handle 1 million objects, then I need the equivalent of domain name server. So essentially over here, shadow object is trying to provide an infrastructure that will be able to handle those kind of things in a more systematic way. So we kind of separate the concern about locating the object, locating where they are, from how I'm going to interact with that. I guess that is, but your point is well taken. If I need to do something special, and well, you will see that the shadow object does not introduce too much overhead anyway. So, but there might be an advantage for developing your own stuff. Yeah. Okay. Yeah, please.
So shadow objects are they're only used to access the original object, not
Yes.
like they don't have any of the, I guess, methods or the same data as the original object. They're just they're just there so we can access.
Okay, that's a good question. I never got to ask that question. Usually I just say yes, but I want to go a little bit detailed because you brought that up. Okay, it's your fault. I'm just kidding. Okay, so we actually can split the functionality into one is remote and one is local, meaning that the shadow object is doing some processing and then the real object doing some processing. Let me give you an example. The first generation of this kind of shadow object is actually for stock market. It's a concept called program trading. So essentially, the real object is the stock that you actually monitor the stock price and decide what stock you should purchase right now. So essentially, you think about that. When I want to doing the program trading with stock market, at that time, right now I'm not sure, but when I first touched this concept, the internet speed is everything. Because if I'm actually remote, then there's a network delay, and such that I lost that competition in the trading, and I will lose a lot. So that's why the big financial company in Wall Street, they invest a lot of money into this kind of technology to make sure they have the fastest technology, be able to take their transaction completed over there. So in that case, the real object is actually New York Stock Exchange, but I have a shadow object that's actually on my machine. So essentially, I only remotely to instruct that object saying that, hey, if you see a price changes or whatever, go ahead, do it. Don't bother to contact me. But sometimes I want to do some kind of analysis and bookkeeping, and I want to do that locally. And therefore, in the more general case about shadow object, your real object could be split. Half of that in the real place, but half of that on your machine. But it is essentially one single object still as this two places. So I mean, there are even more complicated cases which you can actually have in the stock market exchange example. You can actually have the single object be split virtually in different space, but conceptually it's the same object to operate. And that is actually I would say the first generation of this kind of concept was actually developed through the financial market motivation. Yeah, at that time. Okay. All right. So, but I'm not going to go through that. If you're interested, I can tell you that the first generation of this, there is a project called Profit. You can see that the name. the project called Profit when they actually developed this concept. But I'm going to tell you the basic thing is just the shadow and the real is a real one. The shadow is only doing relay the call. Okay. Any other question? All right. All right. So how do I actually do this? There's a few things I should actually tell you. Is that number one? How do I get to know the object identity? How do I know the object identity? And I already provide some hint on this particular slide. It's actually URL. So essentially, every single object in the system, they should have their unique HTTP link. So essentially, because URL, Universal Resource Locator, is a such useful and powerful concept. So obviously, we just use URL. So URL, you probably saw this before, is usually HTTP or HTTPS, depending on what's the security mode. And the first part is the address. I'm actually saying URL is not like that. URL, for example, let me actually write down a particular way you can access an object. Let me get my text. So it could be URL to access an object. Could be something looks like this. cyrus.cs.ucdavis.edu/ let's actually call this ecs36b and / we say class person and / you can probably say something like this. You can say class person and then Felix Wu 1345 whatever. There's some number. Okay, so you can see that this is a URL. And this URL uniquely identify an object that object is actually reside on this particular server. That's a network address, and then under this pass. By the way, in the implementation, you're going to see that it actually can generalize. So this shadow object is actually going to point out, I said earlier, it's a real object, but this itself could be another shadow object. Because if the object moved to the other place, say from one student's phone to another student's phone, then the routing of the information is going to be one shadow to the second shadow, and the second shadow will actually connect to the real object, or you can have as many hops as you want. That's actually definitely programmable. You can do that. But every single hop, you need to have a different URL for you to access to. Okay, so now I'm going to first tell you the programming. There's a few things that once you learned about this, I already mentioned the concept called distributed programming, abstraction for remote resources, or some kind of indirection or dynamics, basically, because objects don't keep changing, and you try to handle some kind of mobility and trackability, and you can all use this concept to handle all of that. And the thing is that in order to implement this one, basically we try to implement how object in C++ then communicate, and we're going to use JSON and C++ to do that. But the important thing that I'm going to teach you a particular tool. This tool is called remote procedure call. How many of you have heard about the term remote procedure call, RPC? Okay, good. Some of you have heard that. So what is a remote procedure call? Usually when you call a function, say in homework 1, you call the function filter words. So we're assuming that the function body and the caller and the callee are actually in the same source code, either compiler or linker, you're going to actually put them together, right? So you have to have the JSON library, you have to have the C++ library, you have to have all the object file, and the linker is going to link them together into one executable and put in the nice memory map that I showed you the other day. So that is called the regular procedure call, because you're calling the function, either you wrote the code or the library wrote the code. So that's called the normal procedure call. So what is a remote procedure call? Remote procedure call is saying that, okay, I'm actually going to make a function call, but that function is really receiving this call is actually totally out of this program. It's probably out of my machine, is in the other corner of the universe. So that is called remote procedure call, or sometimes called RPC. And this become the industry standardized concept for a lot of distributed programming. When you want to deal with things with different, more than one machine, you probably need remote procedure call. So it's called RPC. So let me actually just tell you what it is. Remote procedure call, as example, in a regular function call, the foo call, the same program in the library. But now you actually have two programs. One program is over here. I'm calling it. I call foo. But then this call is actually being routed to another program over the internet. And then that program, that function is real implementation is over there. And then they will actually handle the call. Okay? Yeah.
So, okay, when we use a proxy object, say we have a distributed system and we have a server that just authenticates logins and another server that authenticates sessions, do I keep just one copy of where the login authentication server is, or do I have to keep an object for every user that needs to authenticate themselves, or that any user that needs to log in? So do I keep an object of the system itself, or an object for every person or everything that uses?
So pretty much, if you want to access the remote object, pretty much every single object that's actually you need to use, you need to have a shadow, right? Every single object that you need to touch. And you don't have to load them in all at the same time, but only when you need to use them, then you load it in. But you're talking about the other issue about authentication, right? Because, well, this is really, I mean, by the way, how you're going to authenticate, right? I mean, whether if it's handled with security, then yes, you have to have some kind of authentication mechanism to help you actually be able to access to that. Yeah. But let's first not to worry about authentication, and we will get back to that if we have a more advanced situation. Okay, so here is an example. Let me use this example. Let me actually just, should I jump to that? Okay. No, I think I will skip this. I will come back later. Okay, so we're talking about remote procedure call. I'm going to first discuss how to do remote procedure call. By the way, this is homework assignment number 4. And so you can see that I'm actually starting to push for this concept because it's, by the way, this is one of the hardest homework in my version of ecs36b, just to let you know, okay? Because I think the issue is because this concept is very new to all of you. Once you learn it, you won't forget it for the rest of your life. But the first time when you learn it is kind of, it takes some time, especially when we use a virtual function to make it happen. So I try to get it slow. I want to say an infinite amount of time until you learn this, okay? Either you learn or I fail myself. Okay, that's fine. All right, so, oh, I jumped a little bit further. So let me tell you high level how this remote procedure call works. And by the way, the most popular interface to do remote procedure call. There are basically two different ones. One is called JSON RPC, which I'm going to teach you. It's basically a remote procedure call using JSON as a protocol for them to communicate. The other one, I think is called gRPC. What G stands for? Anybody want to guess?
Generalization.
Stands for a company. Google. Yeah, gRPC is Google's version of RPC. Okay, the reason Google defined gRPC is because they feel JSON is not as efficient as compact. So what is JSON? JSON is human readable. But then Google engineer, they realized, they said, well, I really don't think that when I want to do this, a huge number of remote procedure call, I don't want, how do I say that? I actually don't need human readability like JSON, and I want efficiency. So they basically pack everything into a very encoding. Binary encoding is totally human unreadable, but they actually be smaller and faster in handling that. So that's the difference between the Google's RPC and the JSON RPC. By the way, the concept is exactly the same. It's just the encoding is a little bit different. So it will be good because I know some of you will be probably internship at Google, and you might actually, in fact, this actually make a difference for some of my former ecs36b students, because sometimes you might be interviewed at in a group that's actually using RPC. All right, so it would be good if you have got exposed to some of the detail here. Okay, all right. So let me actually using this. So I'm actually going to tell you this called JSON RPC. So JSON RPC, essentially you're using JSON to describe the interface between the caller and the calling. So this is pretty much like your requirement number 3 when I asked you to actually be able to write that diagram, how the motorcycle is going to talk to car. So essentially you're going to describe the function, but instead you're using JSON to describe that interaction. All right, so that's JSON RPC. So gRPC, I think they're still using JSON to describe it, but then when they compile the communication, the real communication is going to be something else. But in JSON RPC, that you describe that interface in JSON, you also deliver the real call. Everything is also in JSON. It's actually human readable. You can actually see it on the network, how the meaningful information is still preserved there. So it's more readable, but it's slower in that. Okay. So let me actually tell you. So JSON RPC, the core program is a compiler called JSON RPC stub. I basically write it here, JSON RPC stub. So what it does is that it takes the JSON RPC, the JSON specification of the interface, and they generate the code to actually provide to the client side and the server side. By the way, if you want to do RPC, you must have a client side and the server side. The client side represents the one I try to make the call, and the server side is what I will receive the call. So that's why you have a client side and server side. So look at that JSON stub that I described, that I will be able to generate the code to the client, to the server, and then I'm just using it integrated with my own code. This is my own code. I include the client.h over here, you include the server.h, and you get a compile. Now there's two programs, they can talk to each other. So let me actually show you some example. So you can see what it looks like. I've talked about theory, so now I want you to see the real code. Let me take a look where I have it. Let me go to my homework. Let's go to my homework. Homework 3. Yeah, I'll go to my homework 3. It's probably easier. Sorry. Homework 3 is probably the easiest one. So I have this one is called the RPC, JSON RPC specification for this particular homework is actually in JSON. So let me actually take a look at this first part. Let me use Emacs to do that. Okay, should be okay. I hope you can see the character. Okay, so you can see that this part is a function. The function I define, the client going to talk to server. So the function is called getDistance. Remember when I showed you the program earlier in the lecture, I talk about calculating the distance between, say, Woodland, Costco, and IKEA in West Sacramento. The GPS function, how do you calculate? So now we're trying to calculate that remotely, meaning that I have some of the GPS coordinate, they're actually remote. So I define this function called getDistance. It's basically for me to call the GPS object in the remote, in the RPC style. So you can see that I actually have this is the name of the function called getDistance. And the action is a remote call. And then I have some kind of identity, host URL, VS ID, class ID, and object ID. Those are being encoded so I can tell what I want from the other side. By the way, all this are the argument is actually this 1, 2, 3, 4, 5. They're actually with the original call. The way I define the call has that 5 or 4 argument. And then I have to specify what will be returned by the server. So this is the part that the client is going to send to server. This is the part that the server is going to return to the client. And then there is another function called, conflict of interest. Conflict of interest is essentially trying to analyze whether this two-person, I was actually doing a financial transaction and such that there are multiple people, they might have conflict of interest. But the next one will be interested to you. This is operator overloading. I'm actually operator overloading over the remote interface. So that's why I have operator equal equal. So in RPC, I cannot do operator equal sign. So that's why I use the term operator EQ to represent that operator overloading remotely. So you got the idea is that I actually be able to define, this is all about function interface, about how the caller and callee, they need to specify. Okay, with this, now I'm going to run the program. Maybe I will do a make it clean. Okay, I remove everything. So there is a program is going to be generated. It's called HW3 client.h. So now you can see that the program only have HW3 client.cpp. It doesn't have HW3 client.h. So if I try to, let me take a look at my makefile here quickly. Okay. Okay, the makefile, you can see that I have a rule. It's called HW3 client.h. How do I generate HW3 client.h? It's depend on this particular file I just showed you, ecs36b homework3.json. By the way, I restructured all the homework such that this one is not homework for you. It's not homework 3, but this was last time I taught this course. It was homework 3. So you can see that the dependency, I hope you understand the makefile by now, is that in order for me to generate this, I actually depend on the availability of this file. And if you have that file, then I call this program called JSON RPC stub. I call this function JSON RPC stub, and JSON RPC stub is going to use this file and then generate the whole thing. Okay, so that is the way that HW3 client is using. And then you look at this program. Now you can look at my HW3 client.o is basically compiling HW3 client.cpp, but is actually depend on HW3 client.h. So you can see that HW3 client.h is actually needed for me to be able to compile it. So you will actually look at the code is automatically generated, and that code will actually be able to integrate into your program. So that's called remote procedure call.
And for homework 4, do you have the choice using between Google RPC or JSON RPC?
No, you don't have a choice. You use Google RPC. No. You're going to use JSON. Yeah. But I have a student who actually essentially do the same project using Google RPC. One thing is the installation of Google RPC, I would say is not as common as JSON RPC. The JSON RPC, you can use it anywhere. But Google RPC, you probably need to be careful about which version you use. Yeah. Okay. Okay. So now I want to, with this, I'm going to show you. By the way, I will actually send you the code, so you can actually play around. But I want to show you one of the more interesting one. Let me go to homework assignment 7. By the way, this quarter, I don't think I'm going to have homework assignment 7 for you guys because I kind of consolidate them together. So you can see I have a different one. Make a mistake, sorry. This is another JSON RPC function between the client and the server. And this one is extremely simple. I only have 2 functions. One is doing update, one is doing search. So this one is a search engine between the client and the search engine itself. So what it does is that I have 2 functions. In fact, I argue if you have this 2 functions, you can actually build a search engine. So what is the 2 functions? The first function is update. You actually have to post certain thing to the engine to say, hey, I want this to be searchable. That's why you have update. And the thing is that how do you actually represent the information you want to update? You actually implement that as a JSON encoding. So basically, you're using JSON to describe the communication mechanism. You're also using JSON to represent the content, and then just push up there. So that's update. And then for the search is essentially the parameter is just the keyword that you want to search or any kind of criteria you want to search, and you also encode that in the JSON. And then basically you got the return to whatever the result you have or the things you have. By the way, this is just tell you that this will be the last homework of yours. You're going to actually building a search engine that's actually going to using the JSON RPC as a way to be able to communicate. And I should probably tell you that a infrastructure like a search engine might seem really complicated, really big. But the thing is that through this homework, you will see a really, really simplified version of a search engine and try to capture the most important perspective about the modern IT infrastructure we're all using. Okay, all right. You all have a good weekend, and I will continue this on Monday. Really quick. Yeah, really quick. Can you set it up there?